Hi, in this video, we'll be continuing our study of game theory where we introduced the Nash equilibrium in the previous video, and so we will now take a look at more advanced examples on how we identify and find the best response functions and the Nash equilibrium to certain problems. A common problem is in economics, and it is the outcome of the competition between different companies, different firms. And the first model is created by Connaught, where let's say we have a single good produced by n firms, and the cost of the firm is Qi, of producing Qi is CiQi. Then we can put some assumptions where the outputs are sold at a single price determined by the demand. So specifically, if the firm's total output is Q, then the market price is the price at Q. If the output, so now we see that assuming that P is a decreasing function, which it usually is, if the firm's total output increases, then the price already decreases. And if the output of each firm is Qi, then the price would then be P bracket Q1 plus all the way to Qn. And the revenue for each of these is the quantity times the price. And so your profit is actually this quantity times the price minus away your cost. And this model is known as the Connaught oligopoly game. So now we simplify the example where we have a constant unit cost and the demand function is a linear inverse function. And the simplest type of linear inverse function is taking some alpha minus away Q. And for this function, we see that we can assume that C is less than alpha, so that there is some value for the Q. Then, now we assume that now we want to find the Nash equilibrium for this example, and so we need to find the firm's best response function. And firstly, we consider the following case. If the firm's output is Q1 and Q2, then the market price is this. Then the firm's profit will be, using this function over here, will be the following. And we see that if Qj is larger than alpha minus Qj, then the profit will be negative. And so in this case, Qi cannot be optimal. So in any case, it has to be this first scenario. So you already know that the best response must come from here. So we can use this technique, and is doing this. We use from the firm's one viewpoint and treat Q2 as a given. Then for this supposed Q2, we just need to maximize the profit, which is actually just taking the partial derivative with respect to Q1. Because now we expect Q2 to be like a constant. So we just take the partial derivative to Q1 and we equate it to 0 to find the maximum Q1. So in this case, we see that the best response function is the following. And from firm's two viewpoint, it is the same. So we just take the partial derivative of Q2 and we get this as the following. And in that case, now we are able to draw the best response function for both Q1, for player 1 and player 2, and we see that they intersect in the point A minus C over 3. And so this A minus C over 3 is the unique Nash equilibrium. So we can see that this is the Nash equilibrium for the Connaught game. Now we can take a look at another example known as the Bertrand's model of the oligopoly. And the difference is, in the Connaught's game, the firm chooses an output and the price will then be determined by the demand. But in the Bertrand's game, right now is we are choosing the price that we want to set and then just produce accordingly to meet the demand. So in this case, we suppose that the quantity that the consumers demand is the following. So when your price is less than your competitors, then you are able to produce this price, A minus PI. Then if you are greater than your competitor, then no one comes to you, so you produce nothing. And if you're the same, then you share the market. So I hope that's easy to understand in two persons case. So we now say that if we use the marginal cost to be constant as C, marginal means this cost is affected by the quantity. So if firm I chooses the price at PI and firm J chooses the price at PJ, the profit function will be the following. So it is A minus PI, because that's how much you produce, times PI minus C, because this is the net price you earn when PI is less than PJ. When PI is greater than PJ, it is 0. And when PI equals to PJ, you just need to take this quantity times the price minus the marginal cost. And what we see now is that if we want to maximize the profit, if firm 1 charges greater, then it will never earn anything. If you charge the same, then you will earn this profit price. And if firm 1 charges slightly less, then you earn the entire market. So you'll get this. So this tells us that it is most likely that both firm 1 and firm 2 has to produce the same amount. But that's our intuition, and if we were to write it out formally where we make it precise, this is the analysis. So we let PM be the maximizing price for this profit function. So this is the profit function that for both firms. So this is the price charged when the firm is a monopoly. So if that is the case, now we look at the graph. When PJ, your competitor, is less than the cost price already, if you produce less than him, then you'll get negative profits. So the best is you produce anything greater than him, so that you earn a profit of 0, because 0 is larger than negative. So actually, the best response to when your competitor is already producing less than the cost is to produce anything greater than him. So you got this. And if the competitor is producing in between the cost price and the profit maximizing price, then your ability is now, okay, we can increase our price from the cost and slightly below PJ to maximize our profit, but then we can keep doing this until we reach the top. But then when we reach the top, we cannot choose anything already. And if we go from the bottom, the limit of this is also, there's no limit. Then you get all these, if you produce greater than if you produce greater than PJ, then you'll get no profit. So is this. So in either case, the best response function in actually this case is 0, is empty. There's no best response function, because you can always increase to get a better price, and when you're and when you're greater than PJ, you want to go lower to PJ but never approach PJ. And so we need the case where PJ is actually greater than this maximizing price, and we see that in this case your best response is to choose PJ, PM, because at that case you capture the entire market and you still maximize your profits. And in summary, the firm's best response function is given over here. And this is just a further understanding of what is happening, and because it makes no sense that the other firms produce in a loss in the first place, but that is just a weak dominated. The price is just weakly dominated. So we just put it in the scenario because it is a possible scenario. And if we were to write out the best response function, we actually see that it is actually these two lines combined with these two lines. But these two lines don't intersect because it's a hollow circle over here, and the only intersection is over here. So actually the unique Nash equilibrium is when both the prices are produced at the cost price. And intuitively, this just means that the firms will just keep cutting costs until the price reach the marginal cost, and it cannot be further lowered, because if it's lowered further, then you're making a loss. And in this case, both firms earn a profit of 0. So this shows how price war in the real world is not sustainable, as in the long run it will only make sense when both firms stop deviating from each other when the price is at 0. So actually the Bertrand's model is a good example of how price war works in reality. So I hope you find this video enjoyable and now understand two models for economics for firms producing an output. You can leave your questions in the comment section down below and I'll answer them. I hope you have enjoyed this video. Please like, share and subscribe, and I'll see you again. Bye.